Aside from quantitative and qualitative, let's take a little closer look at human movement analysis and the components that make that up. First of all, you can see here at the top of our graph, human movement analysis can be done either through biomechanics or kinesiology. Kinesiology directly relates to how the functional anatomy makes the body move. Biomechanics relates to a division between kinematics and kinetics. We'll talk about those in a second. Further on down the graph, both kinematics and kinetics are broken down into linear and angular movements. What you can see here is that kinematics relates to position, velocity, acceleration. It really doesn't care about how that movement is created. That's the role of kinetics. You can see following down the kinetics graph that it leads to discussions about force and torque. Those are the forces that actually cause the body to move. So again, kinematics do not focus on the forces, they just focus on the movement. Kinetics focus on the forces that cause the movement. Biomechanics also relates to that idea of functional anatomy that is directly related to the study of kinesiology. Let's continue our discussion of this kinesiology and biomechanics. Kinesiology is the scientific study of human movement. It often is used as a term comprised of both anatomical, physiologic, psychologic, and biomechanical perspectives of movement. In kinesiology, all analysis is this idea of qualitative. We describe the movement. We're not using numbers to talk about how it's moved. Biomechanics goes a little more in depth. Now we talk about the laws of mechanics animating motion. And it's this study of how living organisms move and the effect of the forces on the organism. Biomechanics is a much more specific area of science than kinesiology. In biomechanics, this analysis can be both qualitative and numeric or quantitative. We can talk about the values. For example, take a simple exercise like walking up the stairs. In kinesiology, we would describe this as hip flexion via the hip flexors, the vastus muscle group, knee flexion via the hamstrings, ankle dorsiflexion via the tibialis anterior, followed by hip extension via the glutes and hamstrings, knee extension via the quadriceps, plantar flexion via the gastroc. Those terms may be a bit unfamiliar now, but as the semester goes on, you'll understand exactly what we're referring to. The one thing is, I want you to notice that I didn't talk about measuring anything. We just talked about a movement, and we talked about the muscles that made that movement. Now think about yourself going upstairs again. This time, biomechanics, we would need to measure and identify the joint forces at the hip, knee, ankle, foot, and measure the forces between the foot and the stair. That would be done with force platforms. We would be talking about newtons, degrees of range of motion, and the torque in the joint. A very different discussion between the two branches of human movement science.